All right, like you said, my name is Pascal. I work with Dr. Ellen Marsden, and today I'm going to talk about my research on growth and recruitment of juvenile lake trout in Lake Champlain. I'm going to start with a quick backstory on lake trout and Lake Champlain. Lake trout were extirpated from the lake in 1900 for reasons that are not entirely known. Stocking began in 1973 in an effort to build a new lake trout population. So stocking occurs each fall with fingerling-sized lake trout. Each of them have a fin clip to discern them from wild fish, as well as to age the stocked fish without having to kill them. Annual adult assessments takes place each fall at two of the known spawning grounds. One purpose is to collect the brood stock for the hatchery, and the other purpose is to see if there's any wild reproduction occurring. Egg traps and fry traps have been collected on the, have been set on the spawning sites, and we've collected fertilized eggs as well as fry in the spring. So that tells us we do have reproduction that has been going on. But what hasn't been seen is an adult wild population. One of the things that's missing from this study has been a juvenile assessment, because we don't know what happens once the fry leave the spawning grounds in the middle to the end of June. We don't know what happens to them. So that's where Dr. Ellen Marsden and Captain Steve Cluett came in. In 2015, they started a juvenile assessment by bottom trawling. They did this once every 2 to 3 weeks throughout the ice-free season from April till November in the Central Lake, which is right around there, and 2 to 3 times each year in the northern and southern sites, wherever we could find good trawling ground. Just from this 2015 season, we got 3 wild cohorts of juvenile fish and 3 stocked cohorts of juvenile fish, which was a lot of really good detail. We actually had wild juveniles, which was exciting. And one of the key things we got were a lot of data points. So from this, we can compare lake trout from the central sites to the northern and southern sites. We can look at the percent of wild lake trout in terms of, are we seeing more in the central site, more in the northern sites, or southern sites? We can also look at the catch per unit effort from our trawls. We can compare the growth rates in length and condition of the stocked and the wild fish. So it's all these different things that we're able to collect just from going out a handful of times each year. Here are length frequency histograms for wild fish and stocked fish. And this is just from the spring from this year. All I'm going to talk about are 3 quick points here. On the wild length frequency histogram, we have 3 distinct cohorts. That's because the wild lake trout do not overlap in size at these young age classes. Whereas the stocked fish, you'll see that I could only say age 1 or 2 because there's several age 2 fish that are mixed in the stocked age 1 group. The final thing I want to show here is that the age 1 stocked fish are the same size as the age 2 wild fish. That brings us back to when they're stocking in the fall each year, they stock the fish equivalent to the ideal 1-year-old wild fish. So they're already advanced for their age group. And whenever we're talking about juvenile fish in general, and we're looking at recruitment, we need to talk about the critical period hypothesis, which was created by Hewart in 1914. And he really was looking at that first year as the critical time period when you figure out how this year class is going to do. And he focused on 3 hurdles. Those 3 being switching from yolk sac feeding to exogenous feeding as a fry. And when I say fry, I mean a small fish. It's before they've gotten off the spawning reefs. Second is advection. And third is the overwinter mortality due to inadequate stored resources. For lake trout, these 3 hurdles are not hurdles. To start off with, lake trout begin feeding exogenously while they still have their yolk sac. So they don't have a period where they have to learn to forage without getting any nutrients. They're consistently getting nutrients while they're at that young life stage, which is very important. Secondly, the eggs are dropped by the adults into crevices in cobble. So they shouldn't be affected by any flow from the Lake Champlain seiche. So they should be okay until they're old enough to get off the spawning sites, and then they're ready to forage and be able to move around. And finally here, they're a cold water species. So lake trout should have no problem foraging in the winter because the water temperatures are actually ideal for them at that time period. This brings us to the three hypotheses that I've started working on for my research project, and that's saying that the wild lake trout age 0 and older will grow better than the stock lake trout at the same age and the same size. Secondly, I think that feeding does continue over winter, and we can see that because our sampling is occurring from April till November. So we can look at the growth rates during the summer as well as from that November time period through till April the following year. We can compare the length and the condition of those cohorts. And finally, we looked to see if feeding and growth could tell us a little bit of information about the distribution of wild lake trout in the lake. We're seeing mostly wild lake trout in the central section of Lake Champlain, and not as many in the northern and southern sections, and we wanted to see if that had something to do with the differences in length and condition. So this is our overall results from the last 4 years of sampling. I'd like to highlight the percent wild and the CPUE columns. And what you'll see here is that each year the percent of wild lake trout is increasing. And for CPUE, it's also increasing. That's telling us that we're getting more and more wild juveniles in this system. What isn't shown here is that the percent or the CPUE of the stocked fish is not changing. The abundances of stocked fish dropped in each year by the hatchery stays the same. So we're seeing the same number of stocked fish here. We're just seeing that many more wild fish, which is very exciting. Now we're talking about my three hypotheses. This is the first one, looking at differences in the stocked and wild fish, trying to see if there's any real changes there. And when there's a significant difference, it's favoring the wild fish, both in length and condition. And when there is no significant difference, only one time are the stocked fish growing better than the wild fish are. That's telling us that the wild fish are holding their own against the stocked fish, which have been here for, they've been doing this cycle for 40 years. The wild fish, which are relatively new to the system, are holding their own, which is impressive. Now, when we look at overwinter growth, what we're seeing is that the fish are all growing in length over winter. This makes sense because fish cannot get shorter in length at any period of time. That just can't happen. So that's makes sense. It's a good thing to see. Now, condition, when we look at condition, we're looking at the overall health of the fish, the girth of the fish, and that's something that can sometimes get reduced in winter or even during the summer when they're trying to use that energy to gain in length. And what we're seeing here is that for the most part, they're maintaining their condition. That tells us there is foraging going on in the winter because they do need to get, they're gaining in length and they're not losing any condition. That's something that's new to see. Finally, we were looking at the geographic variation of the fish, of the comparisons between the central site, northern and southern sites. And we couldn't get any real trend to develop here. Even though we're seeing more wild fish in the central sites, there was no real discovery found here that gave us anything to come home happy about. To summarize, the catch per unit effort and percent of the wild fish increased every year. That's very exciting. It tells us that the wild fish are doing well right now. The next step is seeing them in the adult population. The adult population are big enough and fast enough to outswim our current bottom trawls. So at about the 3 to 4 age limit is when we stop seeing them in our trawls. Secondly, we see that growth is continuing over winter. This has not really been looked at by a lot of researchers. This is really cool to see because it makes sense. They're cold water species. They should be doing just fine in the winter, but it really hasn't been looked at by very many people. And finally, the juvenile wild fish are growing faster than the stocked fish. This makes sense because the stocked fish are given high nutrient levels in the hatchery. So once they're dropped in the lake, it's almost like a shock to the system. They have to adjust. They have to learn how to forage. Where the wild fish, they have to pick that up right away, or else they're not going to have a chance to survive. The one thing that I would like to see with this wild population, to see really the next step of success, is seeing them coming into the spawning sites. We've seen 3 wild cohorts since 2015, so they should be getting to that age where they should be ready to spawn. I'd like to give a special shout out to Captain Steve Cluett, his deckhands Brad Roy, and Brian Zabel, the Great Lakes Fisheries Commission for providing funding for this project, and the various grad students and technicians that helped out. Do you have any questions? Yes. So the stocked fish, originally there were 6 strains of fish in 1973 that they used, and they found that the Seneca strain was the best strain for our lake. They worked best with the depths and the temperatures. So it's been sort of weeded out the rest of the strains, so it's mostly a pure Seneca strain at this point. But we continue to bring in food stock from the lake, so it's tough to get any sort of genetic analysis going because it's such a muddled population at this point for stocked fish.
Is there a plan to, just in the future, as far as changing the standpoint, to try to get
So we have started doing some gill netting to try and pick up the 4, 5, and potentially 6-year-olds. That's still in the early stages. Once they get past this juvenile stage, they should be ready for they should only be 2 or 3 years away from getting to that spawning stage. So they should be getting to some spawning sites. It could be we don't necessarily know of a couple spawning sites that they've found, but we have a lot of things going on, and that's one of the things to work on next year and this fall. Yes. Why lake trout? Well, lake trout are the apex predator to Lake Champlain. So they do a great job in maintaining the forage base and keeping things on sort of an even keel. Lake trout were the apex predator up till 1900, and then we wanted to bring back the lake trout because we knew that they were what was missing from the lake. Yes. There was a lot of habitat degradation and habitat fragmentation that was going on at that time period. There's also quite a bit of overharvesting, but we couldn't just pin the extirpation on just any one thing. In the Great Lakes, there's a lot of issues with sea lamprey mortality, and this really didn't happen at the same time period. So we couldn't put everything on that boat, even though we'd love to.
Time for one more question.
Go ahead. So once they get to the 4-year-old age class and up is when they start getting the lamprey wounds. Lamprey, the Seneca strain actually is fairly resilient to the lamprey wounds, so they seem to not be affected as much as, say, the Great Lake strains have been, which is encouraging for our fish because at its peak we were seeing 99 lamprey wounds per 100 adult spawning fish, and the highest ever in the Great Lakes was 33 lamprey wounds per 100. We're down to about 50, which is ideal for us. We'd like to get down to about 35, which is the high for the Great Lakes. So our lake trout are more resilient.